Hey everyone, so I want to continue on with what we talked about before. We left off on this slide, so I didn't really talk much about it, but I put it on here just so that you kind of get an idea of why we want to stick with the metric system in this class. Because if you look at the conversions between the US units, they're all over the place. 1 foot is 12 inches, a yard is 3 feet, a pound is 16 ounces, a ton is 2,000 pounds. It makes no sense, and it's really hard to kind of understand what's going on. But if you look over here and compare it to the metric system, it's always consistent. 1 meter is 1,000 millimeters, 1 gram is 1,000 milligrams, 1 liter is 1,000 milliliters, and you notice that it's always a factor of 10. 1,000, 100. I don't have it on here, but you could also have a million and 10. Same, all the same thing. It's just adding or removing zeros, moving the decimal place. That's all converting in the metric system is. Move a decimal place to the left, move it to the right a certain number of times. So this makes life so much easier. That you'll be able to realize that you're on the right track if even if you forget to convert into the proper units, you'll at least know for the most part that you're on the right track because you'll get the same base number. So, for example, if you get 5.5 times 10 to the negative 3 as an answer, but one of the choices is 5.5 times 10 to the negative 6, well, there's a chance that you might have made a unit conversion error. So it kind of allows you to go back and just check to make sure that all your numbers are kosher. So I just wanted to throw that out there. Now, continuing on, this is actually the biggest part of what we've been talking about so far is metric approximations. Now, it's really important in this class that you kind of have an idea of what these metric units actually represent. Like, what is a meter? What is a gram conceptually? If I asked you how many pounds something is, or how many feet or inches something is, you might be able to kind of give a rough idea. We want to do that same thing. Now, you're guaranteed to have to do at least one question on the regions where you're going to have to estimate the size or the weight of something using the metric system, using grams, kilograms, meters, centimeters, something like that. Now, I don't really like memorization too much. I try to avoid it as much as I can. Unfortunately, this is one of those questions that kind of require either extensive practice using the metric system and using metric measurements, or using memorization. Now, to make life a little bit easier, I've come up with some really tricky ways and really simple ways to kind of remember a lot of these conversions, to be able to estimate as much as possible. And I've gone back to basics. I said before that measurement units came from using the things around you, using the human body. So that's what we're going to do here. If you're trying to estimate something in centimeters, what you're going to end up using is the width of your pinky. Now, it's not the length, it's the shorter side of your pinky. A lot of people get that wrong. So, you're using the width of your pinky, and that's going to be about 1 centimeter long. For some people, it might be a little bit bigger or smaller, but again, these are estimations. So, you can use your pinkies to kind of get a rough idea. 10 centimeters would be about approximately your palm's width, so from the pinky to the thumb. That's about 10 centimeters. A meter, I said before, was from nose to fingertips, or if you want to convert, it's about equal to 3 feet or a yard. I mentioned the yard one mainly because I know there are some people who play football. I believe some of the lacrosse players also play on the football fields. So you might actually know distances in yards already. Actually, I believe track too, not on the football field, but they should also use yards. So if you can estimate distances in yards, then just change the word yard to meter, and boom, there you go. Another one, so there really is no way to use your body on this one, but 1 gram is about the size or the weight of a paperclip. So if you're trying to measure something in grams, just try to think about how many paper clips would this be, or another way of saying it, I guess, would be about how many pieces of paper. And then 1 kilogram is about 2 pounds. So you can use a lot of these to kind of approximate things. A really good example of how you can do this. Let's say one of the questions, and this is a question that's come up before, asks you to approximate the length of a pencil. So what you would do on the test is you would look at your pencil, then use your pinkies and see how many pinkies long the pencil is. And you count from one end to the other until you end up getting the number. And for me, when I did it really quickly, I got about 13 pinkies. So what that would say is that that's 13 centimeters. And then I would look for the choice that was closest. That's pretty much all you have to do. So I want to do a few practice questions with this. Now, my big hint for doing this is make sure that you get rid of these numbers when they're written in scientific notation. It's going to make your life significantly easier. And try to use a calculator. All right, so pause the video, work on the self, and we'll go over in a second. Okay, so as I said, you want to get rid of this that's written in scientific notation. Now you have a calculator. I recommend using it because some people will end up getting these numbers mixed up. This number, 10 to the negative 1, is equal to point 0.1 meters, or about 10 centimeters. Now, a lot of people might be thinking the negative 1 means I move the decimal place over. You have to remember that this is 1 times 10 to the negative 1 meters. So plug it into the calculator, you'll see 0.10, which is again 10 centimeters. And if you recall, this is palm. All right, we'll go to the next one. 10 to the 0, when you plug it into the calculator, this is equal to 1 meter. Or remember, this is nose to fingers. And then choice 3 was 10 to the first. This is 10 meters. Now what you would have to do is try to visualize how big 10 meters is. I said before that 10 meters is about 3 feet, so this is like 30 feet. This is about, if I had to estimate, this is about the height of a house. 3-story house to be a little bit more precise. And then 10 to the second, this is 100 meters, or a football field. Now use process of elimination. Of these, the only one that makes sense for the length of a baseball bat is choice B, going nose to fingers. So this is kind of what you want to think of. Now, thankfully, you probably, after a few practice tries, should be able to kind of eliminate a lot of these. And also, these questions do get reused regularly, and there's really not that many. So you see about 10 questions, you've pretty much seen them all. All right, so let me get rid of this, and we'll go on to this next question. So again, pause the video, work on yourself, and try to do the same thing we did before. All right, so this question says approximate the mass of an automobile. So we're going to do the same thing first, get rid of the scientific notation. So this is going to be 10 kilograms. This is 100 kilograms. 1,000. And 1,000,000. And then what we can do is convert these into pounds. If you recall, I said before that going from kilograms to pounds is times by 2. So this would be 20 pounds. This is 200 pounds. This is 2,000. and then this would be 2 million. And then we just see which one makes the most sense. So this is about the size of a toddler. This is about the size of an adult. This is the size of a car. And this is the size of a ship. So again, the closest one is this one. Now there's two things that I want to point out. First, I want to bring your attention that with these metric approximations, there is such a gap between what the correct answer is and every other number around it, to the point where you shouldn't be nickel and diming like, oh well, maybe if there was a truck, trucks would be higher than 2000, or smart cars are a little bit lower than 2000. And you notice the lowest one below it is 200 and the highest is 2 million. So there's no way you're going to have a car this size, and there's no way you're going to have a car this size. So they kind of make it a little bit easier where it's not like it's slightly bigger, it's going to be a dramatic bigger or smaller. Now, a second thing that I wanted to mention is some people might forget whether you're supposed to multiply the number by 2 or divide it. My go-to phrase is that Americans are always made fun of for being fat, so we get the bigger number. So if you have the number 10 kilograms, well, you can either divide by 2 or multiply by 2, but pounds has to be bigger. So that's where we get 20. All right. If you have any questions, let me know. But we'll go on to the next question. Pause the video, work on itself, and we'll go over in a second. Okay, we're going to do the same thing. We don't have to do the scientific notation, but we're going to multiply it by pounds, by 2 to get the pounds again. So 2, 10, 120, and 500. So again, this is like a small baby. This is a bigger baby. This is about we'll call him a teen. And this, I don't really know what I would say 500 is. I'm going to say smart car, like something really small. Again, the only one that makes sense is choice C. While you might think 120 pounds is a little light for a football player, if we look down here, the only other one that's a little bit bigger is 500 pounds. There's no way there's going to be a football player that's 500 pounds. They're most likely going to be around here. Now, another thing I want to point out is I said that these are approximations. So going from kilograms to pounds isn't actually multiplied by 2. It's, I believe, 2.25. But it's a lot easier just to remember, double it and you get your pounds. All right. The last question. So again, pause video, work itself, and we'll go over in a second. Okay. Do the same thing, get rid of the scientific notation. So this would be 10 meters, 1 meter. This would be 0.01 meters, or another way of writing it is 1 centimeter. Now this one's a little bit trickier. 0.0001, or what I can do is move the decimal place 1, 2, 3 times over and get this as 0.1 millimeters. But there is a way that you could figure out the answer without doing this, because as we already said, this is about the size of a house, which is definitely not the thickness of a piece of paper. This is a baseball bat, not the thickness of the paper. This is your pinky, not the width of a piece of paper, or the thickness, I should say. So the only one that makes sense is this one. By process of elimination, by realizing that A, B, and C make absolutely no sense, we're left with the only choice, D. And that's pretty much it for the metric approximations. The next thing that we'll do a few practice things where I'll have you try to estimate and approximate the lengths and masses of things, preferably things around the house. And then we'll do a few practice problems. Like I said, there's really not that many practice problems as far as the regions goes. So again, you do about 5 or 10 questions, and you'll notice that they're pretty much almost all the same after a bit. All right. If you have any questions, you can see me when you come to class in person, or if you want, you can send me a message to remind, or come to one of my extra helps. All right. Good luck and have a great day.